Let's start with transformers related to natural language processing or NLP applications. We are going to look at around 18 applications over the next couple of videos. Okay, so here we are on the Hugging Face landing page. Let's go to models. Now, as we saw in the previous video, on the left hand side, we have all the tasks related to different data types, the computer vision, NLP, etc. Now let's look at text classification. Okay, so we have around 18,000 plus models for text classification, and then here you can sort those using recently updated most likes and most downloads. We probably choose most downloads. Okay, so here we have this model. It's Distilbert model, and you can see it has already been downloaded 2.74 million times. Okay, now all right, so that's how you can filter the models, right? I mean, you can click on the model and it will take you to the model homepage, and here you will find lots of details about what data sets are used to train the model, some validation metrics, etc, right? So depending on what the user has, what details they have provided, you can find all those details here. Now they'll also provide some sample code. Now we are going to so this is how we use the model in its let's call native form, right? But we are going to use the pipelines which abstract away all the details from the user. So the pipelines, even those without any coding experience, they can use. Okay, so in this course we want to focus on different tasks in NLP, different tasks in computer vision, and how to use these models for our applications. It's not about the coding, right? But in pipelines, what happens is it's a two-step process. The first one is a tokenizer, and the second one is the actual model. Okay, now we can use different tokenizers for our model, right? So we can choose different tokenizers and different models as well. So first, our given text, it's been converted into tokens using the tokenizer, and then the tokens are fed into the model to get the predictions we want. Okay, and the pipelines, they abstract away all this from the user. Okay, so let's get into the code. And anything else from here? Yeah, okay. All right, so first you need to install the transformers. That's the most important one. And then a couple of applications. We are going to use this sentence piece and sentence transformers. So you can easily install them using pip. Here -u means the updated or the latest version. Q means install quietly, so it don't produce all the logs while it is installing. Okay, these transformers, they might be they are using number of other libraries like TensorFlow, PyTorch, etc. So if your system is missing any of those libraries, pip will show you, and you can easily find and those install those libraries either using pip or Conda. Okay. All right, standard Python libraries, and then the main one we are going to use is this pipeline. Okay, these we will use later, not important now. All right, so the first one, the sentiment analysis, right? It's the most common and most widely used application in natural language processing, right? We might want to get the sentiment on the movie reviews, maybe the product reviews or feeds, etc. Right? So a couple of years ago, this used to be a big task. We get this data in unstructured format. We clean the data, we tokenize it, or we create features using different methods like bag of words, or maybe TF-IDF, word embeddings, etc. That's before that's after cleaning up the data, right? I mean, we need to remove the common words, the uppercase, lowercase, the spelling mistakes, etc., right? So with the text, we used to do lot of data pre-processing even before we get to the model training, right? But with these transformers, uh, the job becomes so much easier. Now we can, with just one line of code, we can use these pre-built models, right? Now this sentiment analysis become so generic use case, and these models work quite well that we don't even need to train the models anymore. Okay, so that's just within couple of years, what used to be a big challenging task now become one line of code. That's how fast AI is advancing. All right. So the way to use is pipeline, and then here we specify the task we wanted to do. Okay, we can simply specify the task. So what happens is uh, the Hugging Face, if we don't provide a model, specific model, it try to pick up the default model from these models. So from these 18,000 models, they have a default model. Okay, so Hugging Face, they have chosen default model for all the tasks. So for this one, it's this. This is the default model. Okay, so that's the one gets downloaded to your system. Because I already ran the code before, the model is saved in my cache on my local system, so it's not going to download the model. Okay, but when you run this code for the first time, the model gets downloaded, which can typically be around 1 GB to few GB, right? Few models, those are about around couple of 100 MB. So depending on your internet connection, this task might take quite some time, especially if you have low speed connection. Or uh, what you can do is you can run this code on Google Colab, uh, and these models, I mean, several GB of models are downloaded within a minute, right? So the speed is quite fast on Google Colab. All right. So if you don't specify the model, only the task, the default model gets used, and Hugging Face already know for each task what's the default model. Or the second way we can access these models is we have a specific model and we can simply supply the model name, right? So this, we already know what task this model does. But I guess a better approach would be to specify both the task as well as the model name, so that we or the user will know what exactly to expect. What's this model going to do? What's this model going to take as input, and how does the output look like, etc. Right? So be explicit. Okay, be explicit with your task as well as the model name. All right. So, I mean, in this case, even though okay, I'm calling this sentiment. Yeah. So all these sentiment analyzers, they are referring to the same thing really. Okay, because it's this is the default model, and here we are supplying both the task and model, but those are just the same as what we have here and here. Okay. All right. So now we have the sentiment analyzer model on our local machine, and we are accessing the machine model using this pipeline. Okay. So using the sentiment analyzer, we simply supply our input. Okay. So it has three outcomes, either positive, negative, or neutral, and it will give you the label with the highest score and also the score. Okay, and the score for all the labels, the sum will be equal to 1, right? For example, okay, if it's saying 0.96 for positive, the remaining 0.4 will be for negative plus neutral. Okay. All right, so let's start with an example. So here we have a sentence. Now this can be a paragraph, etc. There are some limitations on how long this text can be. That's called max token length. It's different for different models. Again, you can check on Hugging Face web. for any very specific details about the models. But for most use cases, these tokens are typically thousands, so it should work fine. Okay. All right. So I have been waiting for a Hugging Face course my whole life. So this is actually a positive sentiment. So the model has predicted the label as positive and with the confidence score 0.96. So it's very confident, right? So this is right. And here we have another example. This movie is disgustingly good, right? So even though we have this word disgustingly, which has negative connotation, but the user is actually expressing a positive feeling. So the model, again, it detected it as positive and it's almost 100% sure that this is a positive sentiment. And finally, the director tried too much. Yeah, it's a negative sentiment. Again, the model is very confident about it. Okay. So, and then we can do multiple inferences at the same time by providing the input in the form of this list. Okay. So here we have two inputs or records which we have used before. I have been waiting for Hugging Face course whole my life and I hate this so much, right? So this is positive, this is a negative. So here we can see the label is positive and again high score, the label is negative, again a very high score. Okay. So to quickly summarize, we use the models using the pipelines and we can provide both the task and model name or any one of them, but it's a good practice to provide both. And once we have the model, we simply supply our input and it will return the output and the output format, what it looks like, etc. It depends on what the model is doing. Okay. So that's just one task. We are going to cover 17 plus more NLP related tasks. That's it for today. Thank you.